Hello guys, welcome back to my channel Maths on African Motives. Still working on A-level mathematics, that is pure maths. So we shall be focusing in this platform working on differentiation, which is the first part of derivatives for our paper one, mostly where we need to understand the basics concept of differentiation. So in this platform, I'm going to explain the basics that you're supposed to know. So if you're new guys, you can consider me part of the family Maths on African Motives by subscribing so that you won't miss any of the classes that we shall be having from Maths on African Motives. So actually the differentiation part came from your O-level mathematics, where you used to work with the gradient, that is working with the gradient concept there. Remember, from your O-level maths guys, you'll be given a curve and they'll ask you to calculate the gradient of a curve at a certain point, where you draw a tangent to the curve. Then from the tangent of a curve, you have to take your points where you used the formula to represent the gradient as the change in y over the change in x, which you use this formula. It was y2 minus y1 over x2 minus this. We shall talk of this formula in your coordinate geometry there. Yes, we shall work with this formula again, but in this platform we are not going to focus much into this formula. I want you to understand the basics of differentiation, the derivatives. All right, this gradient expression that we are talking about is actually equivalent to the dy dx, which is the derivative of a certain function that you be given of y, which is equal to f of x. So the gradient is actually dy dx is representing the gradient expression. Let's just say the gradient expression. Then it will be the gradient when you substitute the value of x for that point that you be given where you want to calculate the gradient concept. So this dy dx, it can be the first derivative with respect to x. It can be written as dx. So there are so many ways of writing the derivatives, guys, so many ways. Okay, so in this platform, derivatives, they are into many formats. So I'm going to start with first format, where we are just working with algebraic expressions. Algebraic expressions, that is in algebra, guys, that's where we are going to start with. So on these algebraic expressions, we have got the first type, where you are given let's say this format of y is equivalent to ax to the exponent of n. You are given a certain exponent and you want to find dy dx in this case. So this is the formula that you're going to use. You drop the exponent here, you multiply this exponent by a, so it's an x to the exponent of n minus 1. Then you subtract the exponent, so you drop the exponent, you multiply this term by the exponent, then you subtract 1. What am I trying to say? If I am given y is equivalent to 2x to the exponent of 5 like this, that means dy dx is equal to, you multiply 2 and 5, that is 2 times 5, then you subtract 1 to this exponent, which is 5 minus 1. So that will give us 10x to the exponent of 4. So instead of writing this, guys, you can simply see that you can simply like multiply in your mind, okay, subtract also in your mind, then you just write the answer. If that is possible, you can actually do that. So it's actually the first derivative. So this can be given even as a function. F of x is equivalent to 3x to the exponent of 7, like that. Then you'll be asked to find the first derivative with respect. So this f prime x, that is the first derivative. That means the first derivative with respect to x is going to be, I multiply this by 7, that's 3 times 7, which is 21x to the exponent of, I subtract 1 here, so 7 minus 1, that's 6. So it can even go further, where you are asked to find the second derivative. So this one means second derivative, when it is in terms of y is written like this, d2 y over x squared, like that. That is the second derivative. So it means from this part I can even find the derivative again. Multiply this 6 times 1, which is 6 times 2 here, which is 126x to the exponent of, I subtract 1 here, that's 6 minus 1, which is 5. So take note, you multiply by the exponent, you subtract 1 on the exponent. That is the general rule That's our general rule of the derivatives. So now with this general rule, it can be like this case. Now I want to explain. Maybe you are given the typical expressions of y is equal to ax, taking example of y is equal to 5x, like that. Okay, I want to explain maybe with an example so that we can simply see what's happening here. We are given maybe y is equal to 4x. Okay, using our formula, divide x, we say this is to the exponent of 1. So if you multiply 1 times 4, this is going to be 4x to the exponent of 1 minus 1, which is going to give us a 0 here. And we know that any number to the exponent of 0 is 1. So x to the exponent of 0, that's 1. So this simply gives us 1. Then 1 times 4 is what? Is 4. If you do this, try 10x, you'll see that your divide x is going to be 10. So you see that there is something that is happening with this coefficient of x. If I am given a linear expression, this is representing equation of a straight line, which is a linear expression or a linear term. Let's just say work with a linear term. If I am working with a linear term, therefore it means divide x is simply equal to the coefficient of the linear term, which is equal to a. So if y is equal to ax, therefore divide x is equal to a. So it means if I'm given y is equal to 5x, that means my divide x is equal to 5, simply taking the coefficient of x. So this can help you to quicken your way of calculations. You can be much faster if you know this concept. Then the last part that I want to explain is when you are given a constant. Now let's say y is equal to a, where a is representing a constant. Let's just take an example of y is equal to 5. That's a constant. We do not have the value of x here. The derivative of a constant with respect to x is a 0. So there, do not waste your time. Just know that when you are differentiating a constant, you obtain what? You obtain a 0. So that is what you're going to have. And also, if on a condition that you are finding the derivative of y with respect to x, on a condition like you're having f of x plus or minus gx, where you've got 2 functions or 3 functions, or there can be 4 functions depending with the number of functions. Sorry for that, guys. Depending with the number of functions that you'll be given, but they are adding, they are subtracting, whatever that to be happening there. You are going to find the derivative of those terms or those functions separately. That means that will be the derivative with respect to x of f of x that you are going to have in this case, or plus or minus. It can be a plus, it can be a minus, the derivative with respect to x of what? Of gx. So that is what it means. You separate your derivatives. So what am I trying to say? I'm trying to say that if you are given like an expression, this one, it will be an expression like in fact, let's work with examples. I can waste much this. Okay, I have got these questions where asked to differentiate the following with respect to x. With respect to x. So that means this you can try them as equations. It's actually y is equal to y is equal. These are just expressions, but you're supposed to write them as y is equal to. So I'm going to take the first equation. Y is equal to 3x squared plus 6x. That is our first question that we have got here. We want to find the derivative with respect to x. That means this is going to be divide x, and this is adding. So that's why I'm saying you're going to separate this. So you find the derivative of this and also the derivative of this separately. Thus divide x is equal to 3 times 2, which is 6x. Then you subtract 1, which is 1, because you're getting 6x 2 minus 1, which is 1, of which same as 1. Plus, remember guys, what I talked about this, it's a linear expression, so just take the coefficient of x, which is 6. So this is going to give us 6x plus 6. That's our UID dx in this case. All right. So just like that, guys, just like that. That is the concept of derivatives. So don't panic, guys, by the topic to say these are derivatives and so forth. No. Don't panic, guys. Okay, just working on number 2. Y is equal to, it was 8x to the exponent of 3 plus 7x squared minus 3x. That's what we had here, guys. So that means our divide x is going to be multiply here 8 and 3. That is 8 times 3, which is going to be 24. That's 24x to the exponent of, I subtract 1 here, which is going to be 2, plus I multiply here 7 times 2. 2 times 7 there, which is 14x to the exponent of, if I subtract 1, that will be 1, which is just x. Then this is a linear expression, so I'm just going to take the coefficient of x, which is minus 3. So just like that, this is my derivative. So many questions that we can have. What about this question 3 here? How am I going to do this one? It's x squared plus 1 over x. Okay, it's going to be difficult for us to find the derivative when we are having 1 over x like that. So this is what I'm going to do, because I know from my laws of exponents 1 over x came from x to the exponent of -1. So that means I can actually rewrite my equation like this. All right, I can rewrite my equation like that. So now I can apply my derivative. Thus divide x is equivalent to 2 times x. This is like 1x here, so it's 2 times 1, which is 2x to the exponent of -1, which is 1. Just x to the exponent of 1, remember it's x. Then here it's -1 times a plus, so it's minus and a plus, which is -1. X to the exponent of, we subtract 1 here, so it's -1 minus 1, which is -2. So that's your divide x. But just writing this as a positive exponent, remember from your laws of exponents, x to the exponent of -2 means 1 over x squared. So that's what you're going to have now as your final answer. So these are the typical questions. Sometimes they can give you fractions like this. All you need is to understand the concept, guys. That's 4x to the exponent of 4 plus 3x to the exponent of 3, everything over x squared. So what am I going to do? It's a fraction. Okay, this is what I know, guys, from the knowledge of fractions. I know that if I'm given a plus b over c like this, I can rewrite this as a over c plus b over c. It simply means one and the same thing. 3 plus 1 over 7 is the same as 3 over 7 plus 1 over 7. Remember, just add the numerators because the denominators are the same. So that's the concept here. It's going to be y is equal to 4x to the exponent of 4 over x squared plus 3x to the exponent of 3 over x squared. Take note here, I am still simplifying, not evaluating the derivative, just rewriting my expression so that I'll be able to differentiate. This, I'm not differentiating yet, I'm just rearranging the expression here. All right, so that is from your laws of exponents. So you can even see that these are 4 and these are 2. So if I cancel, I'm going to remain with 2 x's here, and these are 3 and these are 2. So I'm going to remain with one of the x's here, which is 3x. So now I'm having a clear expression that I'm supposed to find the derivative from. So this is now my divide x, which is simply 4 times 2, which is 8x to the exponent of, we subtract 1, that's a 1, which is like that. And this is a linear expression. I'm just going to take the value of x, which is 3. So that's it, guys. That's it, just like that. So this is how they ask these questions, and you'll be like, what's happening here? There's nothing that is actually happening. It's just a normal application. So it can be also be like that on number 5, where you're given 2x plus the square root of x. So from this typical question, what am I supposed to do? Also from my laws of exponent, the square root, I know that it was, or it can be written as x to the exponent of a half, which represents the square root of x. If it is the cube root of x like this, it's x to the exponent of a third, back from your laws of exponents. So guys, which law are we applying here? X to the exponent of 1 over n gives us the nth root of x. That is the case. So you're now doing a vice versa now. So this is y is equivalent to 2x plus the square root, which is x to the exponent of a half. So now I can find my divide x, which is equivalent. It's a linear expression. I'm just going to take 2 plus, I drop the exponent, but what is going to be multiplied? There is a 1. If the number is not there, that's a 1. So it's half times 1, which is a half x to the exponent of, I subtract 1 there. So from your calculator, half minus 1, that is minus half. So that's it. So if you are given now to write this, your answer as positive exponents, this is what you're going to do, guys. From this stage, you can simplify further. This is 2 plus, remember, we said to the exponent of a negative means 1 over. So it's going to be 1 over. So it's already, we've got 1 over 2 here by 1 over x to the exponent of a half, where we know that x to the exponent of half represents what? Square root of what? X. So this is going to be, divide x is equal to 2 plus 1 times 1, which is 1 over 2 times x to the exponent of a half, which we said is same as square root of x. So it's 2 square root of x. So this is what you're going to have there as your final answer now. So this is what is important, guys, that you must understand from these basics that we have on derivatives. So what I want you to do is to try this question now on number 6, so that you see what's happening there. So just try, apply your exponents 2 over, like I explained here, but as you can see, it will be a negative on top there. So I want you to try that question and see if we are going to obtain the same thing. So now these are the typical questions. As you can see, guys, it's just a repetition. Given that f of x is equal to this, find f prime x, then the second derivative. So all you need there is a nicer approach. So what am I going to do, guys? Here, this is my f of x, which is equivalent to 5x to the exponent of 3 minus 3 over x plus 2. All right, so the first question is to find the first derivative. All right, so but look at this 3 over x. So just rewrite, guys, your f of x so that you'll be able to see properly, which is 3 over x is same as what? 3x to the exponent of negative 1. So it's minus 3x to the exponent of negative 1 plus 2. Now let's apply our first derivative with respect to x. That's 5 and 3 is going to multiply 3 times 5, 15x to the exponent of, subtract 1 here, that's 2. Minus 1 and minus, that's minus times minus. Here you're multiplying minus 1 times minus 3, which is positive 3x to the exponent of, I subtract 1 here, which is minus 2. Remember, guys, I talked about the derivative of a constant, that it gives us what? A 0. So there you know that you are having a 0. So this is your first derivative, of which just writing this answer in its simplest form, you can just write this as 15x squared plus, take note the part that is raised to the exponent of negative, it's x, not 3. So it's going to be 3 over x squared. So this is how you can write it. Okay, now for you to find the second derivative, which is the item 2 of finding the first, you start by writing your first derivative. And which one are you going to write? Instead of writing this one, which is going to be complex for us to find its derivative, I'm going to write this one, which is already in its simplest form, that I can actually find its derivative in an easier way. So I'm going to write this, which is 15x squared plus 3x to the exponent of negative 2. So this was my first derivative, so therefore it means the second derivative is a continuation from where I was here. I'm going to find the derivative again. So it's 2 and 15 in this case, that's 2 times 15, which is 30, x to the exponent of, you subtract 1 here, which is just 1. Then here it's minus 2 and a plus x 3. So it's minus 2 and plus 3, which is minus 6, x to the exponent of, remember you subtract 1. So it's minus 2 minus 1, which is minus 3. But just rewriting your answer, guys, it's going to be second derivative, which is equivalent to 30x minus 6. Take note the part that is raised to the negative exponent is the x, not the 3, not the 6. So it will be over x to the exponent of 3, just like that. This is now your second derivative. All right, so these are the typical questions, guys. As you can see, we do not want to waste much time. Let us just focus on another particular type of a question. Now they can give us this type of a condition now where we have got using this application, but now let's say we've got something like ax plus b to the exponent of n. This is now our expression, and we want to find the derivative of this. Okay, so from this one you're going to use this concept, divide x is equal to, what you're going to do, you find the derivative of a bracket. It's actually, there's a method that I'll explain those methods later on. There is a method which is called the chain rule that we are supposed to apply here, but we can apply that chain rule by the mindset, by just looking at the question. How am I going to do that? Okay, you find the derivative of the whole bracket. Take note, guys, you find the derivative of the whole bracket, which is ax plus b. So when I find the derivative of the whole bracket, it means I'm going to drop this exponent here, which is n. Remember, there's a 1 here, so it's n times this one, which is just n. So it will be ax plus b to the exponent of n minus 1. So this is the derivative of the bracket. Okay, then you find the derivative of what is inside the bracket now. So here is the derivative of the bracket, just the bracket like this. What is the exponent in the bracket there? Then now what is inside the bracket? You find the derivative of what is inside the bracket. Okay, so this is the derivative of f of x in this case. So let's just say this is your f of x like this. So this is going to be your f prime x, whatever that you're going to have in this case. This is the derivative. So according to this, because this is ax, so the derivative is going to be a here. So that's why you see your equation now, or this derivative written as ax plus b to the exponent of n minus 1 times a. That is why you see now multiplying by a, but the a is just the derivative of the whole function. Now it's not supposed to be like it's an a, because what if it is a x squared plus b? It's no longer a, because here we've got x squared, so it's going to be 2a. So that is why I'm writing it like this, so that you clearly know what's happening here. So where do I apply this type of a derivative? Where you've got these typical questions like this, y is equal to 2x plus 1 to the exponent of 5, or you can be given typical questions like this, y is equal to 1 over 5x plus 3 to the exponent of 4. There are so many typical questions that apply this typical type of a question. So okay, let me start by this one. From this formula, you saw that if you are to find divide x, which is the derivative here, okay, this is our divide x. We said we are going to drop the exponent, that is the derivative of the bracket, the bracket that is just focusing the exponent. So you drop the exponent here, there is a 1 here, so it's 5 times 1, which is 5. The bracket remains as it is, 2x plus 1. Then we subtract an exponent of 1 here. Okay, you drop the exponent, the bracket remains as it is, you subtract 1 on the exponent, so it's now 5 minus 1, which is 4, times the derivative of f of x, which is the whole function inside the bracket. So it's the derivative of 2x, which is 2. The derivative of 1 is a 0, because this one is a constant, so that's why we end up with 2. So I can actually multiply these two. 2 times 5, because these numbers are outside of the bracket, so it's going to be 10 into 2x plus 1 to the exponent of 4. So this is my divide x. So like I said, there are different types of expressions like this one. So from this one, the first thing is we've got 1 over, guys. This is 1 over. So remember, if you are given 1 over from your laws of exponents, if you are given 1 over, you know that is to the exponent of what? Of a negative number. So this is going to be like this, 5x plus 3 everything to the exponent of minus 4. Take note, here there's a 1, so that's why you just leave it like that. But if it was like this, guys, y is equivalent to 3 over 5x plus 3 to the exponent of 4 like this, it was going to be written as 3 into 5x plus 3 to the exponent of 4 like that. So you just multiply by the number that is there, but this one is a negative, sorry, with a negative exponent. So just like this, the negative, but here there's a 1. So now our divide x, remember we said we are going to find the derivative of the bracket. Just close the bracket. drop your exponent here, multiply with the number that is here, which is 1. So that's 1 times minus 4, which is minus 4. We subtract 1 on the bracket. Okay, that's 5x plus 3. Then subtract 1 here, which is minus 5. Okay, this is the derivative of the bracket. Then you find the derivative of what is inside the bracket. This one, your f of x. So this is f prime x, which is 5x. The derivative of 5x is what? It's 5. The derivative of 3, that's a 0. So it's going to be 5 like this. So you multiply minus 4 times 5, which is minus 20 like this. 5x plus 3 to the exponent of minus 5. This is your dy dx. All right, we are still together. So our dy dx now is going to be, this is a negative exponent, and it's the exponent of 5x minus 3, not of this minus 20, but it's of this bracket. So minus 20 is going to remain on top. Then this one, you write it as over 5x plus 3 to the exponent of, now it will be a positive 5. The moment right as 1 over, is now a positive exponent. So these are the typical questions, guys, as you can see, that you're going to relate or to have working with derivatives. So like I said, that it's not like a condition that this is going to be a conditional question. Like let's look at this one. I want you to see this is 2x plus 2 squared plus 3 now to the exponent. So you see now what you're having here. So if you are used to just say I'm just going to take the coefficient there, you're going to be wrong. All right, you're going to be very, very wrong, because this one is going to give us dy dx. Anyways, the derivative of the bracket here, which is going to be 5 times 1, because there's a 1 here, which is 5 into 2x squared plus 3. This repeats as it is. Then we subtract 1 here, which is a 4. That's the derivative of the whole bracket, everything. Then you now find the derivative of what is inside the bracket, which is the derivative of what? Of 2x squared, which is 2 times 2. Remember the derivative, that's 4. Then we subtract 1 on the exponent, so it will be 4x. The derivative of 3, it's a constant, so this one will give us a 0. So that will be plus 0 here, which is just 4x. So this is what you're going to have, 5 times 4x, which is 20x. Everything repeats as it is, 2x plus 3 to the exponent of 4. So guys, as you can see, it's a little bit different from what we had. So it's best for you to know the actual format of the formula, what is happening there. Okay, so these are the typical questions that you have, guys. So I want you to just try as many questions that you can have. I want to try typical questions like these ones, so that we will see if we are together. Typical questions like these ones, to the exponent of minus 3. Typical questions like these ones, 2 over 3x squared plus 1 to the exponent of 6. Yeah, just try and see if you are going to obtain what I'm talking about here. So another part, which is the last part that they can have, that they can give you, is having this question under the square root. Still, you apply the same concept like this one. Square root of 2 plus 3x is another format that you're going to have under when you're given a square root. Why is it possible for us to apply this concept? Because we know that square root simply means to the exponent of what? Of a half. So this part here, I can rewrite this, because this y is equal to, so I can write it as y is equal to 2 plus 3x like this to the exponent of a half. All right, so the moment I can write it like this, it means it's now easier for me to find the derivative of y with respect to x, because I can find the derivative of the bracket. That is, drop the exponent here, it's a half, which is going to multiply to 1 here. That's 1 times a half, which is a half, into 2 plus 3x to the exponent. This is a half here, minus 1. So half minus 1, guys, this is minus a half, which is 1 over 2, times the derivative of what is inside the bracket here, which means you're working with the derivative of 2, which is a 0, the derivative of 3x, which is 3, because remember this is a linear expression, so it's 3. So 0 plus 3, that's 3. So that means we can multiply a half and a 3 here, which is 3 over 2 into 2 plus 3x to the exponent of a negative half. So as we know, guys, to the exponent of a negative half simply means 1 over. So it is going to affect these 2 here. The 3 is on top, so it's 3 over 2 into this bracket now, 2 plus 3x to the exponent of a positive half now, or you can write it as it was before, because we said square root of means to the exponent of half. So this can be written as 3 over 2 into this, which is the square root of 2 plus 3x, the one that we had, 2 plus 3x. So this is your dy dx. So guys, as you can see, these are the typical questions that you are actually going to have, or you're going to obtain there. So I don't know if you are together, maybe the last question that I can just give you guys is this one: y is equivalent to the square root of 1 minus x squared, and I want to find dy dx. So how am I going to find dy dx? Just rewrite this just like the previous question. Is 1 minus x squared to the exponent of a half, like that. Okay, so what is going to be dy dx? Just like what we did from the previous question, is going to be you drop the exponent here, that's half times 1, which is a half, into 1 minus x squared to the exponent of, we subtract 1 here, which is minus half. So this is the derivative of the bracket times what is inside the bracket, the derivative of in the inside part now, which is here, it's a 0 here, minus the derivative of what, of x squared, which is going to give us 2, because you drop this exponent, which is 2 times 1, which is 2x to the exponent of what, 2 minus 1, which is just minus 2x, because it's going to give us 1. So this will give us here minus 2x. So that's what you're going to have there. All right, so it's now you and your simplification now. Half of minus 2x, which is minus x. So it's like this: minus x into 1 minus x squared to the exponent of minus half. This minus x here multiplies this minus 1, which is minus x. Then I can remove this negative on the exponent, but take note, it's for this bracket, not for x. X is just separate, it is not having an exponent there. So it's minus x over, the moment I introduce this, I drop this, is going to be 1 over, like this, 1 minus x squared to the exponent of a half, where this here is the same as this part. Remember, this is where we took it from, so we are just going to write it as over the square root of 1 minus x squared. So that's your dy dx, guys, just like that. So these are the typical questions, guys, that you're supposed to revise along the side when you are working with the derivatives and so forth. Okay, anyways, let us move on to another part where I'm going to explain these the derivatives now in application. Remember, when I started this topic, I talked about the gradients, when you are going to work with the gradient format. Now this gradient that we are talking about is the one that we are going to apply with the derivatives, to say that the gradient, I said, it represents dy dx. So this is not just dy dx, but it is the derivative of y with respect to x at the given point. At the given point, that is the point that you are given. The point is 2, 3, or the point is minus 1, 3, because you'll be given where this point is located, where you are finding the gradient. So what you need is the value of x, definitely, because this is a derivative of y with respect to x. So definitely what you're going to have here is going to be in terms of what? In terms of x. So what you need is, from the point that you'll be given, is the value of x, for you now to find the numerical value of the gradient. So this will be the numerical value of the gradient. By substituting the value of x, you are finding what? The actual value now, which is the numerical value. dy dx is a gradient expression, an expression or a term that represents gradient. but substituting the value of x is now giving us the numerical, that is the actual value now of the gradient. So what am I trying to say? You'll be given this. So how do you apply this? This is the concept. The gradient simply means you divide x, so which means that will be the gradient that you'll be given. Like let's take for example this one. All right, these are the questions. The question is calculate the gradient of the tangent. Okay, like I explained from the first part that when you are to calculate the gradient, you draw a suitable tangent and so forth. But here we want to focus on the gradient, not the equation of the tangent, but the gradient to the following curves at the given point. Okay, we are given curves here that we have and the given corresponding values of x for those points that we have. We are given y is equal to and the value of x. So for you to calculate the gradient, this is what I was explaining, to say that the gradient that we are being asked here represents the divide x at that given point. So what it simply means is that for this one, let's take the first question. Y is equal to 3x squared minus 7x plus 6. It's a quadratic equation that I'm having, which means I'm going to have a quadratic function. So at a point where x is equal to 2, this is where we want to calculate the gradient of the tangent that is going to occur there. So this is what is going to happen. The gradient, like we said, is going to be represented by divide x. So I'm going to find divide x of this, which is 3 times 2. That's 6x. This is, guys, we're now used to this. So it's minus 7. This is a constant, which is a 0. Remember, I talked about this. Okay. So this is your gradient expression. This is your divide x. So therefore, m, which is the gradient, remember m represents gradient, which is the gradient in this case, is equal to the value of x. Now we substitute into this expression, because this is the expression, this one. This is your gradient expression. So you're going to substitute into the gradient expression the value of x, which is 6 times 2 minus 7. Okay, that's going to give us a 5. So that will be your gradient now, the numerical value of the gradient. Okay, so that's the condition, guys. So as you can see, it's just a normal part. So you can even try this question. Just find your derivative, substitute minus 3 there. You must obtain something like 59 here. So I want you to try this one. Okay, let's just try this one together on number 3 here, where we are given y is equal to x plus, okay, this is a minus, sorry, that's a minus there. Okay, that's 3 there. We are given y is equivalent to x minus the square root of x plus 1. And at a point where x is equivalent to what? To 3. What you need only is the value of x. So this is what you're going to have, the gradient, guys. Let us just rewrite this. Remember, we said for square root, that part that we're talking about, the derivative of this format, x plus b to the exponent of n. So we need to write in terms of what? An exponent. So it's going to be x minus x plus 1 to the exponent of a half. Remember, I explained this. Square root means to the exponent of what? Of a half. So we have to find our gradient, because we need the, when you have to find the divide x, because we need the gradient in this case. So divide x is equal to, this is 1x, and you said when it's a linear, you just focus the coefficient of x, which is 1, minus the derivative. Now, guys, we are back to the derivative of that format, where we said we are going to find the derivative of the bracket, which is multiplied by half here, which is minus half x plus 1 to the exponent. I said you subtract 1 here, so that's 1 minus half minus 1, which is minus half. Then you find the derivative of what is inside the bracket, which is x plus 1. The derivative of x, remember, is 1 of 1, that's a 0. So if you add a 0 there, that's just going to be a 1. So yes, not going to give us any effect. So this is what you're going to have, which is 1 minus a half into x. So there's no need for you to simplify this 1 over, because we want to find the gradient, guys, at a point where x is equal to 3. So just substitute on your calculator now to find m, which is the gradient, which is the exact value now of the gradient. Just substitute this point, value of x at this point, which is 3, into x here. So it's 1 minus a half into 3 plus 1 to the exponent of minus half. Your calculator can do this, all these calculations. Your calculator is possible is a can actually simplify this, and this is going to give you 3 over 4. So use your calculator. That's your gradient. So just like that, guys, this is what you have. So this is working with what? With the gradient. So I want you also to try this one. All you need is to separate. I think I talked about the derivative of a fraction when we started on the first part. So all you need is to find this, then you substitute your x, guys. All right, so just try these questions and see. I need feedback, guys. You can actually come back with the question so that I know if we worked on properly. So these, as many as you can, so you can even try these ones. I just want to explain 1 or 2 from these ones where now you'll be given the value of y here, not the value of x. So this one, guys, all you need to is you expand brackets. Okay, I want you to try this. You expand brackets, then you find your derivative, then you substitute. But what about this one? I'm just going to explain this one, then you try the other ones. All right, this is what you're going to have here. You're now given the value of y, not the value of x. Okay, this is what you simply do. That's our number 6 there. Y is equal to 2x squared plus 3x. Remember, the question is to find the gradient, that is the exact gradient, the numerical gradient, value of the gradient. In this case, where y is equal to what? Where y is equal to 2. All right, and we say the gradient expression is given by dy dx. Okay, this is going to be 2 times 2, which is 4x. We subtract 1 here, which is just 1, so it's 4x plus, it's a linear expression, so I'm just going to take the 3. So on this gradient expression, in order for me to find the value of m, or the gradient, the actual value of the gradient, I'm supposed to substitute the value of x. And here I'm not having the value of x, I am given the value of y, not x. So that means I'm stuck. So what am I going to do? All right, simply substitute this value of y into the original equation. 2 is equivalent to 2x squared plus 3x. That means I have formulated an equation where I can be able to solve for x. In this case, 2 to this side is going to be a negative 2 is equal to 0. So as you can see, that's a quadratic equation. So solve this quadratic equation. I don't know, you're going to use factorization, you're going to use completing the square, whatever that you're going to use. All right, factorization, that's 2 and minus 2, that's minus 4x squared. Remember, we need 2 terms that we can multiply to give us minus 4, but when you add, they give you 3, and that's 4 and minus 1. Okay, that's 2x squared plus 4x, guys. From O-level mathematics, if you have forgotten this, you can revise from our channel. Revise your factorization from O-level. You can be able to catch up very fast. 2x squared divided by 2x, yes, 2x plus that's x plus 2. Then here you factor out minus, which is minus 1, which is going to give us x plus 2, which is equal to 0. Here the brackets are the same. That's x plus 2, 2x minus 1 here, which is equal to 0. So x gives us minus 2, or if you transpose to that side, it is going to be 1 over 2. All right, so these are the 2 possible values of x that we're obtaining, minus 2 or a half. So since I now have the values of x, therefore these are the ones now that I'm going to suppose what was missing here, or what made us not to find the gradient, is because we did not have the value of what? The value of x here. Now that we have got this value of x, I'm going to substitute now. Therefore my gradient, when x is equivalent to what? To minus 2, I'm going to have the gradient when x is equivalent to minus 2. All right, so these are the typical conditions that you're having here to say when x is minus 2. So what am I going to do? Let's substitute, guys. When x is minus 2, is substitute here. Therefore our m, which is the gradient, is going to be 4 times minus 2 plus 3. Okay, from your calculator this will give you minus 5. So this is your gradient when x is minus 2. Then when x is equivalent to a half, this one that we obtained here, which is a half, which is 1 over 2, my gradient, which is m, is going to be, substitute half here, that's 4 into a half plus 3, and this will give us something like 5, because this is 2 plus, okay, which is 5. So that's your m there, which is the gradient. So these are the typical questions, guys. As you can see, all you need is the point that you're going to have with the point, then the derivative, and so forth. So I want you to try as many questions as possible. So what about this one now, where you will be given now to find the coordinates. Now they have given you like the gradient. Now you're given here the gradient is there, but what about the coordinate now, the one that gave you this gradient? So this is what you're going to have. Since I am given the gradient, I know that the gradient is represented by what? Dy dx. It is the one that represents the gradient, which is our m, which is the gradient. Okay, so in this case the gradient is 3. So all of what I'm going to do is to find what is going to be equated to 3, which is the gradient, and the gradient is dy dx. So I'm going to find dy dx, then equate that one to what? To the gradient that I'm given, which is 3. From this part of y is equal to x to the exponent of 3 minus 3x squared plus 6x plus 2. I'm going to take this and find the dy dx because it is the one that corresponds with the gradient. So dy dx is equivalent to what? That's the 1. 3 times 1 here, we say 3x squared, we subtract 1, which is squared, minus 6x here, plus what? Plus 6. All right, so that is constant, which is a 0. So this is your gradient expression, this dy dx, which is equivalent to what? To this gradient that you are given of what? Of 3. So you're going to equate now this to 3 so that, okay, let's equate. You're going to see what is going to happen, because we said dy dx is equal to 3. So this is your dy dx, 3x squared minus 6x plus 6 is equal to 3. So that is the case here. So if this is equal to 3, it means definitely it's an equation that I have to solve. Remember, I want to find the point, which is the coordinate, and the point, it consists of x and y. So it simply means find the value of x and find the value of y. That is what the question simply means. So here it's an advantage because I'm now having an equation only in terms of x. So I can be able to solve for x by having this quadratic equation. 3 to the left hand side is going to be a minus 6 minus 3, which is going to give us a 3. So which is going to give us a 0 here. Solve the equation. Yes, I can just even divide by 3 to make things easier. That's going to be x squared, and this will be minus 2x, and this will be a plus 1 equated to 0 like that. So using my factorization or my quadratic formula, whatever technique that you have, you can actually apply this. Since the coefficient of x squared is 1, I'm just going to have my 2 brackets here, working the coefficient of x, working the constant x here. What are the factors of 1 that we have, which gives us minus 2? So definitely it's minus 1 and what? Minus 1. So it's x minus 1, which is equal to 0. So that means x is equivalent to 1 or x is equal to 1. So this is the same value of x. So it means this tangent that we are talking about, this far, whatever that we have, it's at 1 point, because when x is 1, it's just 1 point here. X is 1, x is 1. The question is for us to find the point, the coordinates of the point. This is our question, to find the coordinates. So the coordinate, we said it's made of x and y. So if x is 1, we need the value of y, because we need x and y. So if x is 2, you need whatever value of x that you have. So in this case, our x is what? Is 1. So where are we going to have the corresponding value of y? You substitute into the original equation, this one. That is where you're going to substitute in place of x, substitute 1, in place of x, substitute 1, substitute 1, just like that. And if you do so, you're going to obtain the value of y in this case, which is a 6. All right. So your y is going to be 1 cubed. You substitute x. This is what you're supposed to do on your calculator. Minus 3 into 1 squared plus 6 times 1. This is what you're supposed to indicate on your calculator. Your calculator is going to give you an exact answer, guys, which is 6. So therefore, the point that we are talking about is 1, 6. This is the point where we had a tangent which has a gradient of what? Of 3. This is where we have a tangent which has got a gradient which is what? Which is 3, because we are asked to get a point where the gradient is 3. So I said the idea that is going to work is to use the gradient, because you know that your gradient is represented by dy dx. So you simply find your dy dx, then you equate that one to the gradient that you are given. By doing so, you have formulated an equation in x that you can solve for x. Then substitute y into the original equation is going, the value of x into the original equation gives us the corresponding value of what? Of y, so that it becomes a point, which is the coordinate made of x and what? Made of x and y. So these are the typical questions, guys, that you are supposed to know. Okay, this is another type now that you'll be given. So as you can see, this is just one and the same thing. Find the coordinates of the point on the curve at which the gradient is -1. So this one, it means there are actually two here, because you're given the coordinates, because the cubic function. So we shall have 2 points from this concept. So you just do the normal working, guys. Okay, let me just show you what you're supposed to have here. This is y is equal to 2x to the exponent of 3 minus 4x squared plus x plus 1, like this. All right. So this is what you're going to do. Remember, you are given where gradient is what? Where gradient is -1. So you simply find your dy dx. Dy dx is equivalent to 3 times 2, which is 6x squared, minus 8x plus the coefficient of x here, which is 1. Remember, so you're told that the gradient is -1, which means here I'm going to equate to the gradient, which is -1. So definitely I'm going to have an equation like this: 6x squared minus 8x plus 1, like this. Equate this to -1. So take this to the other side. 6x squared minus 8x minus 1 is going to be a +1, which is going to be +2. So yes, I can use my quadratic formula, but I can even reduce. Even though I'm going to use that quadratic formula, I can reduce this expression throughout by 2, which is going to give me something like this. Then solve using your quadratic formula or factorization. I don't know what is going to be best for you, but you're going to obtain these 2 possible values: x, which is equal to 1, or another x, which is equivalent to a third. So as you can see, this time we are having 2 different values, unlike the previous question where you obtained x is equal to 1 or x is equal to 1. That is why it ended up as a single point. But here now we can clearly see that it was actually going to give us 2 points. So you've got these 2 points. So just like usual, you substitute the value of 1 into the original equation, and your y in this case is going to be a 0. Or you do the same here. Y is going to be 26 over 27. So this is actually what you're going to have. So when x is equal to 1 there, your y is a 0, and another point when x is equivalent to a third, your y is 26 over. You're now writing as a point. Now these are the 2 points. So these are actually the ways, the steps, or the stages that you're supposed to take. So all you need is to follow proper stages and so forth. So all I need, guys, from you now is to try as much questions as possible. So I've got this question that I want you to have. Okay, this one for you to work on. Try this one, and I've already given the answers there. So actually from one of the question papers, we are given that there is a curve that is given by that equation that is equal to a gradient of 4 at a point which is 1, 5. Calculate the value of a and the value of b. So it means there is something that you're supposed to play around, the application of the derivatives, and also the use of the point that you're given. So I want you guys to work on it. Try this one. Then when we are going to meet now, we are going to work on tangents, working on tangents, knowing the concept of tangents, the concept of normals. How do we apply our derivatives on tangents, equations that we have on tangents, equation of normals, solving equations of the point of intersection of a tangent and its curve when it happens again. So these are the typical questions that we shall have, guys. But as we are moving on, let us keep on sharing our platform, our videos, guys, to your friends and colleagues, so that they also can benefit from this platform that we have, Maison African Motive. So let us invite as many friends as possible, so that we also grow as a family till we meet again.